Hello, in the previous video we talked all about subsetting atomic vectors, matrices, and arrays. In this video we'll be talking about subsetting lists and data frames, which works a little bit different than it does for atomic vectors, but there are some similarities. So let's create a list so we have something to work with. First element will be an atomic vector, 1 to 4. Second will be a matrix, and I'm just going to make a matrix with NAs in it, 4 rows, 3 columns. And the third list element will be a function. Okay, now we haven't talked about functions yet, but this is just to demonstrate that basically the elements of the list can be anything. Okay, so let's run that, and let's print out the list. You could see this double square bracket indicates that we're looking at the first list element below it, which is an atomic vector. Here's the second list element, which is a matrix with NAs, and then the third is a function. So the main thing to remember about lists is how double square brackets work. So if you use how double square brackets work versus single square brackets. If you use single square brackets to subset a list, like this, for example, the thing that will be returned will be a list. So if I run this, what's happening here is I'm grabbing the first list element, but it's going to return it as a list of length 1. So the original object A is a list of length 3. Here we're returning a list of length 1 whose one element is the vector 1 through 4. And then you can do the same thing for the other ones. Okay. Now the important thing to remember is this won't say 2, this will return a list of length 1 if you give it one thing. You can also give it more than one thing. So I can give it a vector of list indices I want it to return. And this will naturally return the first 2 list elements. And the return class is a list. Now, if you want to grab the thing that's inside the list element, then you use double square brackets. So a double square bracket 1 will return the thing inside the first element, which is a vector of length 4. The second one is a 4 by 3 matrix. And the third thing is a function. Let's see. There. Okay. Now you can combine these operations together. So let's see. So let's do an example. So let's grab the matrix. So this thing is going to be a 4 by 3 matrix. And then you can directly go in and subset this thing. So you can treat this thing as if you assigned it to an object, and then you can subset that object directly. So this will grab the 4-3 element, which is NA because they're all NAs. But you can also do assignment. So if I want to make that 0 instead of NA and then print it out, now I've modified the 4-3 element of the matrix, which is in the second list element of A. Okay. So, and then the kind of interesting thing, the same thing works for functions. So A of 3 is a function. You can actually go in and directly grab, call this function. Now, whenever you call a function, you use round brackets. So if I want to square the number 7, I index into the list, grab the thing in the third element, which is the function x squared, and then I can call that function by giving it an argument, and it will square it for me. Okay. So this section is to show you that you can train these operations on top of each other so you can index into the list element. Okay, so let's see some more examples to see how these things behave. Okay, let's do this example, and this is one I want you to think about for a second, because now we're really putting together a bunch of operations. So the order of operations will go left to right here. So think about what this is, and then think about what it means to do this, and then to do this. So if you think about that for a second, since we're using single square brackets here, this is going to be a list of length 1 with the second list element. And then since it's a list of length 1, let me just run this part. Since it's a list of length 1, you have to double square bracket and grab the first list element. There's only one, but you grab the first one. So if I run this, this actually returns the matrix because there's no double 1 printed here. And then I can go in and index that matrix. So this is providing combining 3 operations on one line. You can also do what's called hierarchical indexing. So let me just type the code out and then I'll explain what it's going to do. So first let me do this. So we know what this does. This returns a list with the first 2 elements of A. If we give it double square brackets, this operates what's called hierarchical indexing. So what it's going to do is it's going to grab the first list element, and then it's going to go into that element and select the second thing. So this should return 2, and it does. So what's happening here is it's a different way of writing the following. So these 2 lines do exactly the same thing, but in different ways. And this is kind of a common mistake. If sometimes you'll write code where you intend to grab the first 2 list elements and return them as a list, but you'll use double square brackets. And this can be confusing because you will get an answer, but it's not the one you expected. If you want to grab the first 2 list elements, you have to do this with single square brackets. Let's do one more example. So let's do this one. So let's think about what's going to happen here. This grabs the first list element and returns the thing inside of that element, which is a vector. And then this looks like it's treating it as a list and grabbing the second thing. So let's run that line. And it works, but this may not look like it makes a lot of sense because that itself is not a list because we're using double square brackets. So why are we indexing it with double square brackets again? Well, this just works. I don't have an explanation for why. So if you just make any old vector, so this is just a regular old vector, we can index it using single square brackets or double square brackets, and it works the same way. So I've seen some people advocate that maybe you should just always index with double square brackets because it works for vectors as well as lists, but that's not a popular opinion. Most people use single square brackets to access atomic objects, and then if you want to grab the list element from a list, you'll use double square brackets. Well, I'm highlighting the wrong thing. You'd use something like this. If you have a named list, you can use the $ operator to access list elements. So let's look at our object, our list object that's A. I want to give it names, and I could use names as a replacement function like this. And I can specify a vector of names. These names make sense because the first element is a vector, the second is a matrix, and the third is a function. And if I print out A, now instead of printing out double square brackets with the number, the list index, it's printing out $ with the names. So now you can do a $vec, a $mat, a $fun to access the elements. Now $ operator will always return the thing inside the list element as opposed to a list containing the list elements. If you have a named vector, you can still access them with square brackets. So this will still work. This will still work. If you do double square brackets, you will strip the name because you're returning the thing inside and it's the list element that is named. You can also specify the name just like you can with a named vector. So this will return a list. So if I were to do class of this, it's a list. And you can also do double square brackets. And as expected, this will not return a list. It will return the element in the list element. So if you do the class of that, this should just say integer. Okay. Now, one thing to worry about is that the $ operator does what's called partial matching. So let's look at an example. $MA. So when I start typing, it should tell me, what list element it thinks I'm trying to extract. So I could type tab. However, if I didn't know that and I just made a mistake and wrote $MA, this will still work. So basically it's looking at what you supplied to it and it's making an inference about what you want it to get. And the way it makes that inference is it does partial matching. So since there's no other list element whose name starts with MA, it knows you are trying to get MAT. It does not do partial matching when you use names with double square brackets. So this will return null because there is no list element whose name is MA. And I believe the same thing for single square brackets. This returns null, but it's a list of length 1 whose only element is null. Okay, so this probably was useful at some point for making code shorter. I guess it still is, but I don't recommend intending to write code like this. This is very confusing. People are not going to be expecting to see that. It's also, I think I consider indexing in this way to be safer because if you're not intending to do partial matching when you're indexing lists, you could make mistakes, and it won't. So say you match something that you didn't intend to. There's no error that's giving here. So say you were expecting to see a list element whose name was MA, and you typed it in. It doesn't tell you here, there's no warning that gets printed out. It says, there's no element called MA. I'm going to return the one that's called MAT. It just gives you an answer. So this is a bit safer because it at least gives you null, and you can test for that. Okay, so this will give fewer silent bugs. So I recommend when it makes sense to do this in like production code. If you're just messing around with data, this is obviously $MAT is obviously a lot shorter to write. There's fewer characters here. There's only one operator and there's no quotes to write, so it's a bit shorter, but when you're writing code that has to be right, I recommend using this kind of indexing. Okay. If you want to eliminate a list element, you can assign the value null to that element. So let me make my list, or let's just check to see if we have it. Yeah, we still have our list here. So if I say $, $fun is null, and then I print out A, we have removed essentially the fun list element. So now it's a list of length 2. And it has removed the fun name from names as well. And you can do this. You can do this in using the $ operator. Let me write this whole thing out so we can repeat it. So let's repeat this. That prints it out. And we can use double square brackets as well. All right, so that will remove it. And you can do, you could use numeric indexing. So let's just show that real quick. That removes it as well. Okay. I think this works for vectors. Let me try this as well. Again, I recommend you, here's some, I was just curious, does it work for vectors? I recommend you do this kind of thing on your own. If you have questions that pop into your head and you're following along, just go ahead and type them out. Pause the video, type them out, and see what happens. Okay, it doesn't like this for vectors. The error it gives is replacement has length 0. So what R is doing here is it sees this thing on the right-hand side. Like we said before, null is a generic length 0 object. So the way it's working for vectors is trying to take that length 0 object and put it in a spot that has room for one thing, and it's giving an error. Now that's not how it works for lists, but this is how it works for vectors. Now, as we talked about in a previous video, a data frame really is a list with the property that each list element is an atomic vector of the same length. So while data frames are rectangular shaped, so they're kind of like matrices, they're also like lists. So they, when we go to subset data frames, they will sometimes behave like a matrix and sometimes like a list. So let's create a data frame here. And to make it interesting, I want to make it a data frame with 2 different types and 2 different columns. So there's my data frame. The first column are the first 10 letters. Second column are the first 10 integers, positive integers. And the name of the first column is lets. The name of the second column is nums. And they're also row names by default 1 through 10. Okay. So we can grab a single element from a data frame by treating it like a matrix and using 2 indices. So if I want to pull out the element in the 5th row first column, that's going to be the letter E. You do it that way. And of course, you can put in whatever you like. If you, you can do things like this. So you can grab an entire column, just like you can do with matrices. But what you should remember is that the return type of this thing will be an atomic vector. So this is no longer a data frame. You can tell that because it's not situated like this. It prints everything out like it's an atomic vector. The same thing will happen for the second column. Now, if you do it for a row, it will not. And if we think about this, it will not coerce it to atomic vector. So this still looks like a data frame with just one row. We can verify that by saying class. And I think this behavior is good because these two things have different, aren't required to have the same type in a data frame. And so it's returning a data frame with one row. So it's avoiding coercing them to be the same type, which would have to happen if we coerce this to be a vector, because these atomic vectors all have to have the same type. All right, but just to remember, if you had a data frame and you're trying to grab all the elements from one row and expecting it to be a vector, it's not going to be a vector. You can also grab multiple columns. If you grab multiple columns, the return type will be a data frame. So this looks like a data frame. We can verify that by doing class. And so as you can see here, all you have to do is give it the vector of which columns you want. If you give it in a different order, it will respect the ordering. So this was the second column in the original data frame. That was the first column. And you can repeat columns. I'm not sure why you'd want to do this, but you can repeat columns. So here we're saying grab all rows, because I'm leaving it blank, and I want columns 2, 1, 2. Oops. So it returns a data frame where the first column is column 2 from the original, the second is column 1 from the original, and the third column is column 2 from the original data frame. However, it changed the name to be nums.1 instead of nums. That's because you can't have two columns with the same name in a data frame. All right, so most of these examples, we're kind of thinking of the data frame as a special type of matrix. We're using single square brackets, and we are using two indices or vectors of indices separated by a comma. Now you can also treat the data frame like a list. So if we do this, let's think about what this is going to do. So if we said before that a data frame is a list where each list element has to be an atomic vector of the same length, and those atomic vectors are the columns. If we do single indexing on that, think of it as a list, and grabbing the first one, what it should return is a list of the first list element. And since it's a data frame, now it's going to be a data frame with a single column. Okay, so this is important to remember. So this will return a data frame because we're using single indexing, and that returns the list. And we could do class of that to verify. So the analogy here is, let's see if we still have this. Okay, here's our list. The analogy here is A1 is itself a list. Since data frames are list-like, if I do dat1, this will return a list as opposed to, let me type it over here, grabbing dat double square bracket 1, which returns the thing in that list element, which is the vector a through j. Okay, so if you do single index subsetting, it will return a data frame, which can be quite useful. You can also combine these things, so you could do dat. If you think about what this has to do, it has to grab list elements 2, 1, and keep it as a data frame. So this will return a data frame. Now if you give it, as we saw above, if you give it multiple indices, it will kind of work like a matrix. It just grabs the element. It doesn't try to keep it as a data frame. Now if you're using single brackets separated by commas, you can also use the column names. So I could do dat lets. This is equivalent to doing, let's print dat. This is equivalent to typing dat, comma 1. So this will return a vector because we're using the double indexing here. We can also put these together in a vector. This will now return a data frame because there are multiple columns, whereas this returns a single vector. And then if you don't put the comma in, this will be like treating it like a list. So this will return a data frame. So this is equivalent to typing dat 1 as we did above. Okay. Also, you can access columns using the dollar operator. So if I do dat $lets, but here there's a couple of issues. It will use partial matching, so that works when you might not want it to. And it's going to coerce to an atomic vector. So there's no way to use the $ operator to make it return a data frame. And then you can also combine these operations. And this is true for all the ones above as well. You can grab the first 4 elements. So you'll see lots of code like this if you look at other people's R scripts where they're grabbing a column from a data frame and they're indexing into it somehow. All right, as we saw above, you can also use double square bracket on data frames. So if I do this, so recall that the difference is that this will return the element inside that, the thing inside that list element. So this will return the atomic vector. You can index into that. If I want to grab the third thing, that will give me C. Technically, you can do this. And if you think about what this is going to do, if you're using a vector inside of double square brackets, it does hierarchical indexing. So what's going to happen is going to grab the first list element, which is the first column, and then the third element of that. So this should also do C. But so I'm just going to make a note here. This works, but not recommended because this is very confusing code. Okay. And then you can also use names with double square brackets. So that should work. That grabs the nums column, and just like with the index numbers, you can also index into it. Okay, last thing I want to talk about is the subset function. So I'll leave the documentation for you to look at. But the way you use this is you can take a data frame as its first argument, and you define the subset argument as a logical vector. So, okay, so what's going to happen here is, first of all, this code doesn't work on its own because there's no object whose name is nums. However, when this code gets evaluated, it gets evaluated assuming dat is there, and it assumes that this is a column from dat named nums. So when this gets evaluated, it will work. So if we do this, it's grabbing all rows of dat for which the nums column is greater than 6. So it grabbed the last 4 rows. Nums are 7, 8, 9, and 10. And the corresponding rows, the corresponding values of lets are G, H, I, and J. Just to see how this works, let me type this out, how you would type it without using the subset function. You would say dat of dat $nums greater than 6. And I want to get both columns, so I'm going to leave that blank. So this is telling me this is going to be a true-false vector. It's true for the last 4 elements because those are the ones for which dat $nums is greater than 6. And then I'm grabbing both columns. Okay. So different R programmers have different tendencies. Some like to use a subset function. Some like to make it all explicit here. Where do I fall? I probably fall more in this camp because I don't like that there's a piece of code sitting out here that actually doesn't work on its own. So I would probably write it this way, but different people have different preferences. So it's good to know about the subset function. You can also use the subset function to grab specific columns. So you could say select equals lets. That will grab the letters column. And it does keep the result as a data frame. This is equivalent to doing this. And let me move these down here so it corresponds with the comments. All right, so what I'm saying here is these two calls to subset are equivalent to these two indexing operations on dat in a different way. Okay, so that's subsetting for list and data frames. It's important to keep track of the difference between how single square bracket subsetting works. In general, that returns a list or a data frame versus double square bracket indexing, which will give you the thing inside of the list element or the thing inside the column of the data frame. Okay, so we'll see you next time.